Hi, this is lesson 12.4. We want to deal now with linear equations. Now we're moving into 3 space, and with that, if we have linear equations, that would form what we call a plane. So we've done some examples of this, but we want to look at and try to write equations for these planes given some information. So we want to write the equation of the plane that cuts the x-axis at z equal to 4, has a slope of -2 in the x direction and 1/2 in the y direction. Now some things to note. If you do the slope parallel to the x-axis, it will always have the same slope. And then if it's parallel to the y-axis, they will always be the same as well. But they're different from each other. These two are different, usually from each other. Then the slope, if we always walk in the same direction, will always be the same. So if I'm always walking on the plane this way, the slope is always going to be the same. And then if we walk in various directions, obviously the slope will change on this tilted plane. I made an error here. This should be the z-axis. Okay, it cuts the z-axis at z equal to 4 and has a slope of -2 in the x and 1/2 in the y. So that means if I'm going on my plane, I can start here at this point right here, number 4. And then this would be my, in the red, would be my x direction here. So as I slide down this plane, I'm going to slide down right here. My slope is going to be -2, right? So then this is in the xz plane that I just drew this line right here. Now what happens when we go in the y direction? We have a slope of 1/2 in the y direction, and so I'm going to be going up 1 for going over 2. Now I drew these 2 lines in here, this one and this one, because they are parallel to this axis. So this is all the 4s, this is all the 5s that are parallel to this y-axis. So I'm going to go 1, 2 units this way, and then I'm going to go up 1. That would give me a slope of 1/2. So I'm kind of going in this direction here, and so and it's hard to tell. This is hard to do, but this is my y-axis. This line right here is right above that y-axis, and then that will follow my plane in that direction. So how are we going to write this equation now? Well, if I start right here at my point that I do know on the z-axis, I want to represent the height. So if I go in the x direction when y is 0, so I ignore the y's really, I'm going to be going on a slope of -2. And so when I go over 1, I'm going to go down 2. So for each x value that I go over, I'm going to go down 2. So this is going to be equal to -2x. So this is the slope in the x direction. Now if I'm in the YZ plane, I got x equal to 0, and so I'm going to be going along this line right here. Well, how do I go along this line? Well, if I go over 2, I go up 1, so it's going to have a slope of 1/2. So how I represent that with the y is plus 1/2 in the y direction. What I've neglected though is where did I start? And where I started was at z equal to 4. So my 4 should go in here. And so if I write this properly, I'm going to start at 4. And then if I go in the x direction, I'm going to go down 2 over 1. And if I go in the y direction, I'm going to go up 1 over 2. So that's my equation right there. And so that's how you kind of start. So if I want to do a general form of the equation of a plane, I can do it right with this formula right here. Now these points right here, x naught, y naught, z naught, that could be any point that you're given, and you're going to start at some z, and then you're going to go in the x direction by a slope that I have right here. Now you might not be on the xy plane or the yz plane or wherever we are, so then we use that to account for it and the y naught to account for it. But m is the slope in the x direction, n is the slope in the y direction. So here's my equation that I end up with. And then here, this is something fancy that just says solve for the constant. So when I multiply these two out and multiply these two out, put them together with this, then I'm going to get this formula right there. That's all that says. So we have this now down here is that this is an example. In 2 space, a line is determined by 2 points. So in 3 space, a plane is determined by 3 points, provided they do not lie on a line. So what I want to do is write the equation of the plane passing through these points right here. Now, to make this easier, you might end up with 3 equations, 3 unknowns. To avoid that a little bit, I've matched up some of the coordinates. So this is a 1, this is a 1. So that makes it a little bit easier. And then I also have, what else matches up? This one here is a -1, this one here is a -1. If I do that, that makes writing this equation a little bit easier. We'll find out in linear algebra that you can write an equation for three unknowns, 3 equations, 3 unknowns, a little bit easier than what we're doing right now. So here's how this is going to work. If I have the same y coordinate, then what I can do is I can find slope in the x direction. Because what I'm going to be is in a single plane within that x direction that's going to be parallel to the x-axis. So let's try this and see how this works. So if I have the same y coordinates, so that would be the first and second ones here. What I want to do is find the slope. So the slope is going to be my change in z, because I'm doing it parallel to the x-axis, over the change in x. So my change in z here is going to be, so I said the first and second one, right? So then I'm going to take the change in z, which is 3 minus 0. I'm going to divide it by my change in x, which is going to be the -1 minus the 2. So I'm going to end up with -1. So my slope in the x direction, if I start with some z coordinate, is going to be -1. Similarly, if I have the same x coordinate, I can find the slope in the y direction. Why don't you pause this and try that one? So I ended up getting a value -1 minus 3, so I get the -1 minus 3, and then over 2 minus 1, so 2 minus 1, because the x values are fixed. Same thing, so then I can just break this down like this. Now I just go ahead and write my formula. By picking one of the points, it doesn't matter which point you use. How about if I use this one right here? So I pick the point 2, 1, 0. And then I do have my slopes. So z is equal to z naught plus m times x minus x naught plus n times y minus y naught. And I put this together. So using one point that I did pick, and then using the slope -1 and then the slope of -4, I can write my equation of this plane. Try graphing this on GeoGebra or on your calculator and see that that does come out and satisfies those 3 points. And so I can take the other 2 points and just check these, that they do work, and sure enough, you check that equality. For what I plugged in there, they do work, so it does work out. And so look at this equation again. This is my overall height. This is some starting height that I do have. So how do I change? Well, this is going to be my change in my x direction. This is going to be the change in my y direction from having my initial z here. And that's what's happening, is that these are just changing x direction and y direction. So that's all that formula does for us. Okay, so we represent this in different ways. So a linear function can be recognized from its table by the following features. Each row and each column is linear. So that means that the rows will have the same slope within that row, and the columns will have the same slope within that column. Although the slope of the rows might not be the same, may or may not be the same as the columns. Usually they're not the same. Okay, so you're going in the x direction with one slope, y direction with another slope. That's all that means. So how can I figure out this missing value? Now remember, these right here, these are your x values. These right here are your y values. So if I look at this, I see delta y is equal to 0.5. Well, what happens to z as I change delta y by 0.5? Well, delta z is going to be equal to 1. So if I want to find my n is going to be delta z all over delta y. And so that would be 1 divided by 0.5, which is equal to 2. Try to find out what happens on the x here. See if you can figure that out. So my change here is positive 1. And when that happens, my z's change by negative 1. So if I put that together to find my slope m, I'm going to get a negative 1. So what would this thing be right here? Well, I'm going to increase by 1 going here, and we also found out that we're going to decrease by 1 by going this way. So either way that I look at it, this value should be 0.5. Now what if I wanted to write the equation for this thing as well? Well, remember, you need a point. And so when I have the point and I need the slopes, I do have the slopes, but which point do you want it to do? Well, I can go x being 2, which should be right here, y being 1.5, and then z would be my 0.5. And then I know my slope m is negative 1, n is going to be 2, so this should put together very easily with my formula. Plug it in, you get this, and then if you simplify, you get this right here. Okay, let's use our contour map here that we do have, our contour diagram, to write the equation of this plane, the linear function. So what we need to do is, well, let's find m. Let's find n. Why don't you pause this and look at this before we even start and see if you can find both of those. And a great starting point might be right here to go x direction, y direction. So thanks for pausing and trying this. Remember, in this direction, I'm going to do a change for z divided by a change for x. So if I start here and I walk in the x direction by 2, so that would be a change of 2 in the x direction. What happened to my z's? Well, my z started at 0, finished at 2, so that also changed by 2. Now let's look at in the y direction. So if I start right here and I go down, well, that doesn't hit spot on. I do know that if I go down here by 2, I'm going to hit spot on to negative 6. So my change in z would be negative 6, and my change in y would be down by 2. So I went down by 2 here, and then my z changed to negative 6. So I'm going to get a slope of 3 there. So now use a point. This point right in the middle is the origin. That one is on the plane, 0, 0, 0, because the z value adds 0, 0, 0. And so then I just write this as z is equal to 0 plus my slope in 1, x minus 0, plus my slope in the y, which would be 3, y minus 0. And voila. We wrote the equation of our plane. So a lot of this is figuring out what's my slope in the x direction, what's my slope in the y direction, and get a point, then you should be able to write the equation of the plane. There you go. Here is your gift. I'm working on these as we go along, so give me feedback if this is too much, too little, whatever you want to say. Thank you.